The third case will be presented by Mrs. Silvia Takey. Silvia will talk about the PSS at DEV.
Hello, good afternoon, everyone. My name is Silvia Takey. I am an industrial engineer here at USP and a master's graduate degree too. I'm going to present the case of innovative Internet of Things application to enable PSS. I was glad to hear a lot of times the IoT word in the previous presentations. I am Director of Operations of DEV Tecnologia. DEV is an IoT design house and original design manufacturer here in Brazil. And we are, to our knowledge, the only one in Brazil developing end-to-end solutions in IoT. And what do I mean? What do I mean about end-to-end? We develop from the electronic hardware to the software application to the customer. Talking a little about our team, we are 4 partners, all from Polytechnic School at USP. In fact, we are a spin-off. We have an agreement with the board here at Poly to be called a spin-off of Poly, and we are incubated at CETEC, which is an incubator of companies here in the campus. Camilo is our CEO. He's like, I kid that he's like Steve Jobs and Wozniak in the same person. He's doing electronics since he was 9. He opened his first company at 14, and is leading the strategy in the company. Pes is a hardware director. He's specialist in digital hardware, embedded software, and is electronic engineer. He projects circuits in his garage since he was 13. Arthur is our software director. He also has a lot of experience and started programming at 11. And I am responsible for the administration of the company. I'm COO, certified in project management, and I kid that I boss the guys since I was 3. And we have another 12 collaborators, 1 PhD, 4 masters, 16 engineers or graduates. We also have big partners here in Brazil. We are design partners of Microchip, Texas Instruments, Atmel, which are the main producers of the semiconductors which go into IoT devices, and also other companies supplying software and other services. Explaining a bit about Internet of Things. Many people are misguided by this name, thinking it's the same thing as Internet of People, but it's quite different in terms of technology. The hardware you need is composed by sensors, microcontrollers, unique ID, and embedded software, which we call firmware. Besides that, you have to have connectivity, so Wi-Fi, RF, Bluetooth, or wired connectivity, Ethernet, and you have to think about the whole security of data in this transmission. You also need to have gateways connecting the sensor data and the internet, so routers or smartphones with special protocols. HTTP, which is the protocol we use for people, is generally too large for things. Things need to communicate in very small packets with no overhead messages in order to be effective. And most applications also use the cloud technology, cloud servers, time series database, and you have to always think about scalability, because when you have 100 connected devices is one thing. When you have 1,000, 10,000, 1 million, it exponentially grows the amount of data. And by the end, you have to have an application. only the data of the sensors does not create value to anyone. So you have to have all the interfaces transforming data into knowledge to the customer. And we work from concept development to commercial product. Besides the services, we also have products which enable Internet of Things. So DEV Connect is an IoT enabler, which is also what the concept we used in the case I will present from PSS. It connects a great amount of sensors with many protocols and meters, and you can access the data in an online dashboard and also have a remote actuation. So instead of having a huge system from Siemens or ABB, you can have one small box which can connect your machine to the internet through Wi-Fi, RS485 or Ethernet or other communication technologies. We also have micro-location enablers, which are devices which send Bluetooth Low Energy messages in order for you to do asset management. So you can, with this technology, you can locate all your things inside a room or a plant and have this information over the internet. And to finalize about DEV, which we now have over 30 clients, including Intelbras, Vivo, Natura. We also have a lot of media insertions. We have been granted, especially from FAPESP, and one of these projects was the PSS enabled by IoT. And now we are on the growth path. So, talking a bit about the context of the case. We have been granted innovative grant from FAPESP. It helps small companies to invest in research for innovative products. It's a non-refundable fund, so that's the greatest part about this. In this project, we helped Rochman, which is another company, is incubated here at the University of São Paulo. It develops an industrial solvent recycle for a chemical products manufacturer. It's a national technology. They developed that in-house. And they intended to the business model to be a rental with monthly payments and having a percentage of cost savings as revenue. So they wanted to be in the PSS, although they didn't know it had this name by then. And the chemical process was distillation. The differentiations they wanted to have in the market was safety and durability. And but on the other hand, they had very simple controls, like interlock circuit based on sensors and contactors with manual configuration and no intelligence on it. The team was DEV Tecnologia. I was the main researcher, and we also had Zanku as associate professor, and also Kaushik from Federal University of Santa Catarina in the team. And now in phase 2, we will have Marley to aboard. Talking a bit about the challenges, further details of the methodology of how we came up with these challenges, how we discovered this, will be provided by Zanku on Wednesday. They had a very difficulty in detecting operator misusage of the machine because it had to be set up with specific temperatures and cycle times, but the operator changed it without anyone knowing, and you could damage the machine for good. They wanted to have a remote setup in case of fluid substitution. So nowadays they have to go there, they have to visit the plant in order to do the setup. They wanted to assess machine status, so to see if everything was correct, check operational parameters, and monitor usage, how many cycles, how much time, and this could provide valuable information for billing. And also, obviously, detect early failures. In the technology point of view, what we did was we replaced all the sensors in the machine for digital ones. Before they were just on and off switches. We adopted a low-cost PLC, which we could, which had open software, so we could change all the firmware, all the software that was embedded there. And the interlock switch was entirely replaced by this technology. The connectivity, we used local Wi-Fi, and we know that not only in this case, but in many cases in Brazil, the connectivity is still a big problem. So what we did, we used these repeaters, so the connectivity from the office could reach the plant, which was in another level in the building. For a gateway, we customized a router with embedded Linux and OpenWRT. One thing we noted is that we are leaning very much towards open source protocols, not proprietary ones. We believe very much in this trend in IoT. And we had serial communication between the machine and the router. We used Amazon as a cloud server. We used this MQTT protocol, which is very, very, very lighter, much lighter than HTTP. And we use a time series database. What does it mean? It means that you can have a lot of data which have a measure and a timestamp, and do reports of months, of days, of years of your machine with very low cost. And we did an internet application, an online dashboard. It was a web software which you could not only see everything that was going on with the machine, but also to input the parameters online. All you had to do is internet browser and internet. Talking about the results, we replaced this panel with contactors with this control. So inside here you have microcontrollers domaining the logic. And to show you some results of the tests, we had a temperature sensor which sent data to our dashboard. So you could see a dynamic graph of how the temperature was behaving, real-time reading at that time, how many degrees, and also the state of the machine. So you can have a complete report, even though you were not there, of what's going on with your machine. Like this, you can also have a graph of the states, so you can compare what's going on with the sensor and the state of the machine and see if they are connected, if they make sense. And also, we have a micro switch for lead opening detection. So you could see a visual alert if it was open or not open, which was another example of misusage of the operator. During the process, he wanted to open, or before it was the right time, he wanted to open the lead. And now you could have this alert. And also, we had a remote input of process parameters, so you could have the heating time, the temperature of all stages of the process. And you could also export the data of a selected period in CSV file for further analysis. For instance, if you wanted to know how much time they spent in the process, or consolidate how much solvent was actually recycled during that time, you could do that by exporting the data. And what we see as business model for PSS with IoT. We see ourselves as original design manufacturers, so we're going to supply these gateways which enable the machine to be connected, and we expect to have a high volume platform so that integrators, which are ITC and industrial automators integrators, or value-added resellers of this product. I used to compare this product to Cisco routers, Cisco ecosystem. Cisco also only develops and sells products in order for distributors and integrators to install in the final customers. And we also have complementers. Data analytics and intelligence providers or supervisory system providers are great complementers of this solution. All this is delivered then to the manufacturer, who can now offer services instead of sales, gain higher margins, automatic billing based on usage, maintenance at affordable costs, and faster assessment of customer needs. If you assess the profile of usage of the machine, you can understand his needs in advance. And finally, the final customer, talking about benefits of having IoT, is you can also monitor usage. So how much solvent am I recycling? This can be an important data for instance, for reports, sustainability reports they do yearly. And also monitor the service level agreement with the supplier of the PSS. And our next steps is to do the phase 2. We are pre-approved for this project in phase 2. Now we will have 1 million to develop our final project. We have now a partnership with Dow DuPont, which also wants to implement IoT into water purification containers. They have this itinerant solution, and they want this solution to be connected in order to expand globally. And we want to develop original design of DEV Machine Connect. As I've shown you, the router which connects to the internet is now a third-party one we adapted. And now we want to do an original one and be able to manufacture it in large scale. We want to test in further operational scenarios, not only inside the company in the controlled environment, but in real life scenarios. And that's it. Thank you very much.